The next paper is on experimentation of usage of PQC algorithms for eSign by Pavan Gloria, Ankita Bhargava, Srikant, Sailada, N. Subramaniam, Janavi Bodhankar, and Ajay Kumar.
Good afternoon, everyone. So I am Srikant from CDAC Pune. So we have been working in the project of eSign. So we wanted to implement the PQC NIST approved PQC algorithms and test how it can be implemented in eSign process. So first I wanted to know, say simple things about what are the effects of quantum computing in present scenario. So at present we use RSA or ECC mainly for eSign process. So by introduction of quantum computing, it can use Shor's algorithm or Grover's to break and or we can say weaken the present algorithms such as um, RSA, ECC, and AES. Here Shores uses like uh, prime factorization. It can break prime factorization mainly. So which affects RSA and also ECC. When it comes to Grover's algorithm, it actually makes the search algorithm faster. So usually for AES 128, it takes 2 power 128 bits, 128 iteration to find the solution. But when it comes to Grover's, it can like it can like square it off n times of complexity. So to overcome this, post-quantum cryptography has been established. So post-quantum cryptography is nothing but like cryptographic system. It has to be protected against classical and also quantum attacks. So it uses, presently it uses lattice-based cryptographies, code-based, hash-based, and multivariate-based, and etc. So NIST has started this standardization of PQC algorithms. So it actually has 5 levels of security based on how much it can break AES 128 or SHA 256 and AES 256 and AES 384. So these are security levels from level 1 to level 5. So based on that, sub, whoever submitting the papers have to implement either 1, 2, 3 and also in 4, 5 security levels. So first I wanted to introduce about eSign. So eSign is an online platform where a user can get electronic signatures done for his documents. So in this process, we have mainly three parts, which are application service provider, eSign service provider, and eKYC service provider. So in application service provider, user can provide his document to be signed. So application service provider actually converts this document into hash and sends the hash value to eSign service provider. Then eSign service provider authenticates the user by getting eKYC details from eKYC service provider and also generates key pair on behalf of the user. So here we can use ECC or RSA to generate the key pair. So then we generate CSR and send it to CA to get it signed. So even for CA we have key pair which can be RSA and ECC. So here then our CA sends back the digital signing certificate back to eSign provider in PKCS 11 format, whereas eSign service provider includes this hash and the certificate in PKCS 7 format and sends back to the application service provider. So our idea is to like how we can which algorithms can be used in place of ECC or RSA for generating key pairs on behalf of user and also for the CA certificate. So usually in this third round, actually Crystal, Dilithium, Falcon, Sphinx, Gems, Picnic and Rainbow were selected, but after completion, only Crystal, Dilithium, Falcon and Sphinx were selected. So among these, Crystal, Dilithium and Falcon are lattice based and Sphinx is hash based. So crystal dilithium is a lattice-based algorithm. Its structure is based on fiat chamber with aborts, which is non-interactive zero-knowledge proof. And it, the strength of this algorithm depends on module learning with errors along with the short integer solutions. So it has mainly 6 variations, which are dilithium 235 and dilithium 2AES, 3AS and 5AS. So in dilithium 235, shake is used, whereas dilithium AES 256 is used to in some mathematics followed during the key generation or digital signing. So in Falcon uses GPV framework, which uses hash then sign method, and its hardness is based on short integer solution problem over NTRU lattices. So comparable to other lattice-based algorithms, Falcon provides smaller, shorter signature size with the same NIST security level. So in a NIST, in Falcon we have 2 variations, which are Falcon 512 and 1024. So here Falcon 512 provides NIST level 1 security, and whereas Falcon 1024 provides NIST level 5 security. Another finalist was Pink's Plus, which is a stateless hash-based signature scheme. So it has multiple tree levels, whereas we have a parent node and it has child nodes, and every child node again has some child nodes. So in that way, the tree is a hypertree with multiple level of tree structures, and then each child node is uses OTS, which is one-time signature scheme, whereas the bottom level child uses few time signature schemes, which so that it can become stateless. If we go with only a one-time signature scheme, it will be stateful algorithm. So even here, Spinks provide multiple variations, which are using the hash algorithm, very different hash algorithm, such as SHA-3, SHA-256, and Haraka. And again, these variations have sub levels depending on how, if it is a simple, depending on the size, and also fast operation, and simple or robust. So these have the variations, and also depending on the NIST security level, it provides NIST security level 1, 3, and 5. So I am extending these algorithms with respect to final round. So we have Picnic and also Rainbow for the final round, but which could not get shortlisted. So in Picnic uses zero knowledge proof along with hash functions and block ciphers, whereas Rainbow uses multivariate algorithms where it depends on it follows unbalanced oil vinegar structure. So even it provides NIST security level 1, 3, and 5. So what our experimentation was developing a QSign platform where we use OpenSSL fork, which provides these NIST finalized algorithms using OpenSSL. So in the second point, you can see the algorithms which are present, which were present inside the OpenSSL fork. So we used these algorithms to generate CSR and also to sign these CSR using a CS certificate. So we also made we also have to analyze the performance. We have a page where for given number of iterations, how much time does the CA take to sign the paper, sign the CSRs. So these are some screenshots of our eSign platform, and these are the results where for I think 25 number of times it has to sign. So how much milliseconds of time does every algorithm takes? So here we can see Dilithium and Falcon take less time when compared to other algorithms. So these are some comparison table where we have security level, public key size, private key size, signature size and signing time for each signature. So for usage in the eSign, we were thinking to use with the NIST security level 3 and above. So from these algorithms, we were considering only dilithium 3.5 and also Falcon 5 because of these security level, and also when it comes to signature size and signature signing time. So we are like thinking to consider dilithium 3 and Falcon 1024 whenever they are available for in terms of HSMs, because we usually use HSM to generate key pairs for the user and also to sign the CSR certificate. So in our future aspect, we are thinking to provide PQC algorithms in complete eSign flow, where a user can upload the PDF and we can embed this digital certificate using this post-quantum algorithms inside that PDF. Thank you. Yes.
What is the difference with the eSign? If the algorithm is changed, is it different?
Actually in the what we say structure, it makes the difference, like what type of OID it provides, so it will be reflected inside the certificate structure.
In the eSign paper, how do you check?
Sorry,
eSign paper,
yeah.
how do you check?
When we embed the
Like bank says it has been e-signed, right?
yeah.
So now how do I check?
Actually, in terms of PDF, when we get e-signed, you can see that in Aadhaar we get green tick or question mark. So when we open that green tick, like click on that, our certificate gets opened actually. So inside that certificate, user details, CA details, and also I think CCA details also, we can look into the details in the certificate.
Thanks.
So it proves the authenticity of the user and also signer.
No, I have asked a question, how the timings compare with RSA or ECC?
Oh, okay. Actually, we did not compare with the RSA and ECC right now. We are comparing only these algorithms, like PQC algorithms at present. Because
Okay.
RSA
No, but,
and ECC
no, but
are quite,
but it will be interesting to know, does it take a lot of time to
yes.
put a post-quantum signature, or that is, what is the position?
Actually, RSA and ECC take less time when compared to these PQC algorithms.
No, by how much? That is the question.
Oh,
Okay.
how much?
Don't worry.
We did not compare actually. Yeah.
Okay.
Thank you. Sir. Thank you.
Okay. You showed us, I think, falcon, picnic, rainbow, and species, right?
Yes.
So this is being like used for, signing the certificate, or it can be used even for signing the document.
Signing the document itself. If eSign flow itself is signing the document.
Means you will be signing the hash of the document,
Yes.
right?
Yes.
Okay. So in the signature, in the signature response when we get, right,
Yeah.
when you submit it. So is there any change in the response of the signature, like the size of the response? Anything you have been identified?
We actually right now we did not include these algorithms in eSign flow. That is what I mentioned in future scope. We are thinking to like compare again with the RSA and DCC with the present dilithium 3 and Falcon in the eSign complete flow. Right now we did not make any comparison with eSign complete flow.
Okay, thank you.
Yeah.
One more last question. What version of OpenSSL you have been used to do this?
It is actually OpenSSL for 1.1 something.
Okay.
Yeah.
Thank you.
Thank you, everyone.
Are there any HSMs that support the PQC algorithms?
Right now, they are like, what we know is there are some manufacturers, they are ready to provide, but not complete HSM. Like, even they are like implementing the SAID algorithms from C program into hardware and they are ready to provide it, but officially they are not there yet.
Okay.
Thank you, everyone.